This next one's for you folks to try, and because these are so time consuming, I've chosen a problem from the homework so that doing this problem now you're getting a head start on the homework. This is problem number 65. We're using function notation here, so remember p of x, we're just calling the function p. P of x is just a fancy name for the y value. So I'm asking you to graph it and of course include at least one full period and label the 5 important points. Okay. And then state the amplitude, period, phase shift, vertical shift, domain, and range. This is basically the directions, except that the book didn't ask for the domain and range. I threw that in there. So pause the video, try and work that out, then tune back in and check your answer. As always, the first thing I'm going to do is get the input to cosine into factored form. So I'm going to factor out that negative pi over 2. So that's being multiplied by x. Factoring out a negative will change that sign to a plus. And I'm essentially dividing by pi over 2. That's like multiplying by 2 over pi. So that's going to make that a 2. Let's double check. If I distributed a negative pi over 2 to that 2, that would give me back my negative pi. All right, by doing this, now the negative sign applies to the entire input. Cosine is even. Opposite input, same output. So I get to ignore that negative sign. Not this one, but this one. So we get negative cosine pi over 2 times x plus 2 plus 2. Beautiful. Okay. So I can see all of this is my input to cosine. That's going to affect things horizontally. The stuff that I'm doing after I evaluate cosine is multiplying by negative 1 and adding 2, and that's going to affect the graph vertically. Okay, so if I keep track of my vertical stuff, we start with a high, middle, and low of 1, 0, and negative 1. We do the multiplication first. Multiplying by negative 1 won't change those values. They'll still be 1, 0, and negative 1. 1, of course, maps to negative 1, and negative 1 becomes 1. What it does is a flip. So with a regular cosine graph, I would start high and go low. I've done a flip here, so I'm going to start at the bottom going up. So start low, going up. Okay, and then we add 2. So this was my multiplying by negative 1. This is my adding 2. So the high value is going to become 3. The middle value is 2. And the low value is 1. But I'm also going to indicate that we're still starting low and going up. Fabulous. Those are going to be the y values that I care about. 1, 2, and 3. All right. So for the x values, I know cosine does its thing once as the input, which is pi over 2 times x plus 2, varies from 0 to 2 pi. Let's solve that for x. So I'm going to divide by pi over 2. Now over here, dividing by pi over 2, probably going to be better to write that as multiplying by 2 over pi. So we're going to get 0 divided by anything is 0. Less than or equal to x plus 2. Less than or equal to the pi's cancel, but 2 times 2 is going to give me 4. Then we subtract 2 from each piece. So we get negative 2 less than or equal to x less than or equal to 2. All right, so the new period should be, let's calculate it both ways, should be 2 pi divided by the absolute value of what we were multiplying by, which is pi over 2. That would be 2 pi times 2 over pi. That would be 4. Notice ending point minus a negative 2 starting point becomes 2 plus 2 becomes 4, so that checks. So the new period is 4. Oh, this is nice. That means that the new increment, since we always divide our graph into 4 subsections corresponding initially to the 4 quadrants, that's just the period divided by 4, which is 1. Ah, gotta love it. Okay, so let's see. I'm going to erase the work that I did up here. Let me keep that result that we're going from -2 to 2. So the x values that I care about are going to be -2, and then I'm just adding 1. So -1, 0, 1, 2. Adding that increment 1, 2, 3, 4 times took me to my ending point. Beautiful. I'm going to just copy this last vertical axis here so that I can erase that. So again, the crucial information is that the y values I care about are 1, 2, and 3, and I'm going to make sure that we start at the bottom going up. Let me actually keep that version of the equation up. Okay, so as we're graphing, the y values I care about are 1, 2, and 3, and again, not absolutely necessary, but I like to just draw in dotted lines. Those are the grid lines I would have at those heights if I were working with graph paper. And if you want to work with graph paper, you're more than welcome to. Totally allowed. Okay. All right, so I'm going to mark off my x values of -2, -1, 0, 1, and 2. Do just be careful. Note that 0 is one of those important points so that we don't skip over it. Okay. And now in plotting my points, we're starting at a low value. So at -2, we're down here at 1. At -1, we're at a middle value of 2. And at 0, we're at a high value of 3. At 1, we're back at 2. At 2, we're back at 1. And so I can connect the dots. And there's my beautiful graph. So the amplitude, that should be the absolute value of -1. Since -1 is what we were multiplying by, that's 1. That makes sense. We didn't do a vertical stretch or shrink, so the vertical distance between the high value and the middle value is still 1. Okay. Notice, I don't really care how high the high value is. I care about how far it is from the middle value in calculating the amplitude. The period, we said that was 4. We calculated that along the way. Okay. The phase shift. Now, if I've written it in factored form, I can see we're moving things 2 units, and because we were adding 2, we're moving 2 to the left. And that makes sense. We started at an x value of -2. That's 2 to the left of where we usually start, which is an x value of 0. And the vertical shift, that's accomplished by adding 2. And again, remember what you want to look at if you're interpreting that graphically is how high did we move the middle value to? We moved that up 2. Excellent. Domain for any sine or cosine graph is all real numbers, so -infinity to infinity. And the range is just the closed interval. It'll always be brackets for sine and cosine between the low value and the high value. So that's the interval from 1 to 3. Good stuff.